Hello ladies and gentlemen, welcome to my video. This video we're going to solve summation for a series involve trigonometry functions. It looks similar to the previous video, however, for this one the solution does not require integral or differential calculus, but rather highly focus on Euler formulas. First, rewrite the first term become divided by 1, which is 1 factorial. Meanwhile, 2 is actually 2 factorial, 6 is actually 3 factorial, and 24 is 4 factorial. We can rewrite Q become summation k equals to 1 to infinity. Numerator is sin k pi divided by 2, while the denominator is k factorial. In order to suit to exponential function letter, we prefer to start from k equals to 0. When k equals to 0, we have sin 0 divided by 0 factorial, which is equal to 0. So we just have to add a 0 in front, nothing else need to be changed. Q supposedly an answer in terms of number. Let's try to rewrite as a function qx equals to summation of k equals to 0 until infinity, sine function of kx, and then divide by k factorial, where x is pi divided by 2. Next, we're going to use popular Euler's formulas, where e power I theta equals to cosine theta plus I sine theta. In our case, theta is kx. I is imaginary number which is equal to square root of -1. This equation gives us a complex number which is the real parts equals to cosine kx, and then the imaginary parts is equals to sine kx. In this video, we only deal with the sine kx, so therefore, real part is never used. Replace the imaginary parts into the equation. We have the new qx equals to imaginary part of sum of k equals to 0 until infinity, e power I kx divided by k factorial. Let's go back to the basic definition of e power y, which is equals to 1 plus y power 2 divided by 2 factorial plus y power 3 divided by 3 factorial, and so on, which means sum of k equals to 0 until infinity, y power k divided by k factorial is equals to e power y. If we look at these two equations, easily we can find that y is equals to our e power ix. Therefore, we can rewrite q equals to imaginary part of e power ix. This is a good news because no more sum and no more k. We just have to deal with x equals to 1 over 2 and get the answer. But wait, not that simple. We still need some derivation required us to use Euler formulas. Here we have e power ix. We need to change the e power ix become cosine x plus I sine x, which can be further simplified become e power cosine x multiply e power I sine x. Using Euler formulas again, e power I sine x is equals to cos sine x plus I sine x. Put it back to q, we have qx equals to imaginary part of e power cosine x multiplies cos sine x, and then plus I multiply e power cosine x multiply sine x. For the first part, there's no imaginary number I, so it's a real number that does not related to what we want. The second part gives us what we want, therefore we have qx equals to e power cosine x multiply sine x. Remember, we define x equals to pi divided by 2, so therefore we have q equals to e power cosine pi divided by 2 multiply sine pi divided by 2, which is equals to e power 0 multiply sine 1. That brings us to the conclusion of this video. The final answer of this question is sine 1, or approximately equals to 0.84147. Thank you for watching my video until the end. Please continue support, subscribe, give a like and share my video with others. See you in the next video. Bye bye.